In this video, we are going to solve the Leetcode problem of the day, and the problem is maximum value of an ordered triplet, part 2. Now we have solved another question similar to this yesterday, maximum value of an ordered triplet part 1, and we have already drawn the solution for this yesterday only. But let us try to understand this in deep in this video again. So first of all, we will try to understand what is this question all about, and then we will try to understand what is the approach and the intuition behind the approach to solve this particular question, and then we will see the code, the optimized code in Python. So first of all, let me take you to the drawing pad and try to explain you this particular problem. In this particular problem, we are given an input, and input is an array of numbers, and we have an output. Now, how do we process this input to get an output? Let us see. The task is to find the maximum value of a triplet which we can form using any three indexes I, j and k, such that the index I is less than index j and index j is less than index k. So this is the relationship between the I, j and k, and the value of a triplet you can form is using this formula, nums of I minus nums of j, and that will be multiplied with nums of k. So this is the question all about. You just need to find those three numbers which you can take from this array and form a triplet, and the value of the triplet should be maximum. For example, in this input you can take these three numbers 12, 1 and 7. This will be your index number I, which is 0. This will be your index number j, which is 2, and this is your index number k, which is 4. Now you will see that the I, j and k, this relationship holds correct. So we can form a triplet with 12, 1 and 7, and then put this into your formula. So this will be 12 minus 1 multiplied by 7. This will be equal to 77, and that is your output. You can see here. Now we can form another triplet, for example 12, 6 and 1. But if you put this into the formula, the output will be 6. And we want the maximum value, right? And that is why we are taking 12, 1 and 7 as our triplet. Now the first approach to solve this particular question is using brute force, and the time complexity for this will be O of n cube. It means we are going to run 3 loops which will be inside each other, and those 3 loops will be for index I, index j and index k. How can you do this? This will be very simple. You have few numbers, right? For example, indexes are 0, 1, 2, 3, 4. You can simply take 3 loops I, j and k. I can start from the starting index 0, but the value of j has to be more than I. So j has to be I plus 1, which is 1, and k has to be more than j. So in this case, k has to be j plus 1. So k will start from index number 2. Now run these 3 loops, and every time you get a unique set of indexes, try to put this into the formula, and then you can find the value of a triplet, and you can just maintain a variable result which will be initially 0. And each time you find a new triplet, try to see if it is more than your current triplet value, and if it is, then put this into your result variable, and at the end you can return this result. But the problem is this is going to throw time limit exceeded error, okay, TLE. Now let me show you. If I go back to the code editor, and I have this solution which is using 3 loops. You can see this is the first loop for I, this is the second loop for j, and this is the third loop for k. And inside this I'm trying to form the result by taking the maximum of my current result value and putting the I, j and k into the formula, and at the last, out of the loop, I can return the value of the result. This code is correct, but the problem is it is throwing time limit exceeded error. So you can see the sample test cases are fine, but if I try to submit this, I'm getting TLE error. So right, you can see 563 out of 599 test cases are passed. It means the code is correct, but let us try to optimize this code so that we can avoid this TLE error. So let me go back to the drawing pad and try to explain you the optimized version of this code. The optimized version is going to be O of n time complexity, that is just a single loop will be required, and O of 1 space complexity, that is we will not need any extra spaces apart from few variables. Now let me try to explain you guys the approach to solve this particular problem in O of n time complexity using this dry run table. What we are going to do is we are going to process each data in our input one by one, and at each point of time, at each index, we are going to store 3 things: the result at this point, the maximum number which we have got till this point, and the maximum difference which we can create at this point. So whatever index we are at, we will try to find these 3 variables, and at the end the maximum value will be 77, or whatever the input is. Based on that, the output will be different, but at the end we will have the result storing the maximum output. That is our answer. Now why do we come to this particular solution? That is the first thing to understand. Think about the formula. This is your formula to find the triplet. In this triplet, there are 2 factors. So this is the first factor, and this is your second factor. Both are getting multiplied, and since we have basic mathematics saying that if you want to find the maximum of 2 numbers which are getting multiplied, then these 2 numbers or these 2 factors has to be maximum, right? So if we are able to find the maximum difference of 2 numbers and multiply it with another number, which is our multiplying factor, we can say, then the output is going to be the answer, that is the maximum value. Now let us try to find the answer at each index. First of all, we are having just one index 12, right? When we are at index number 12, our result is going to be 0. So initially our result will be 0. And the question says that if the maximum triplet which we have found after processing all the input, that is all the data in our array, is negative, then in that case 0 should be our answer. So for that we will start our result at 0. So let's say our current value of result is 0. Now at this point of time, what are the different values which you can have for this and this? The difference factor and the multiplying factor. Well, you cannot have a value of nums of k, and the reason is we need to align with the constraint that I should be less than j, which should be less than k. So if the value of k is 0, then j will be -1 and this will be -2 at least, right? So, and we cannot do it, right? So when we are at I, that is index number 0, at this point of time, we don't have a k and we don't have a j as well. So right now, we will not have a difference and we will not have a result, and both will be 0 for now. So we are going to start with 0 and both are going to be 0. But we have got one value here, the value of I, the possible value of I, and this should be maximum, right? Because if you want to create this as a maximum and we are using the minus operator, so if the first number is maximum and the second number is minimum, then we can create the maximum difference, right? So the maximum number is something we will keep track of at each point of time, and that will be our I. So this is going to be our I. What about j? Now at this point, when you are at index number 0, you don't have a j, right? So the difference and result is something you can ignore. Next is when you reach to this index, now you have another option for I and one option for j. The option for I is 6, but the value of I is already 12. So do you want to use the new value of I, which is 6? No, we do not want to use it because we already have a better value, which is more. So 12 is going to continue. 12 is going to be our maximum value till now. But can we create a difference? Now I is 12, right? The option for j is 6 now. We have an option right now. So we can say 12 minus 6, which is equal to 6. So if we choose 6 as our j, the difference we are getting is 6, which is more than the difference we already have, right? So if the value is more, then this factor, the difference factor, is going to increase, right? So in that case, we are going to say, okay, the difference will get updated. So the moment we process 12 and 6, we can say that this is our I and this is going to be our j, right? So that our difference is 6. But we still don't have a value for k, right? So still the result is going to be 0. Now you have another value which is 1. Again, you will have the three options. 1 can be your I, can be your j, and can be your k. Do you want 1 to be your I? Well, we already have a value 12, right? The current value of I is 12. So I don't want this as a value of I. But do you want this to be your value of j? So yes, we can have this as a value of j. And the reason for that is the current difference we have is 6. If we change our index j and put the index j at this point, then at this point of time, the difference which you can create is 11, right? So 11 is our difference if the value of I is 12 and the value of j is 1, right? So we are going to say, okay, you are going to be my new j. But if this is your new j, then you will still not have a value of k, right? Because then this cannot be your k. So now you have two options. If this is your j, then 11 is going to be your maximum and result is going to be 0 because you do not have a value of k. But if this is not your j and this is your k, if you put this as your k and put this as your j, then in that case you will see that the difference, which is 6, can be multiplied with the new k, 1, and that is 6. So the maximum result as of now you can get, right, is not 0 but 6. This is something which you can create. So let us say this is our triplet when we are processing the input as 12, 6 and 1. But we are not sure this is our complete input because we still have 2 more input to follow. So what we are going to do is we are going to say, okay, my result at this point can be 6. That is the maximum we have, but I can have a better result. So I will keep my result as 6, but I am hoping for a better result. And for that, I will say this is my j as of now because that is going to increase the value of my difference and my difference will become 11. So we are shifting the value of j. We are creating a difference of 11, but we are still storing the result as 6, right? Because we have a possibility of creating a triplet as a value of 6, which is better than value of 0, right? So at this point of time, my result can be 6, right? My difference can be 11 and the maximum value, which is 12, which can be your I. And we are going to do the same thing with the other inputs as well, 2 and 7. What you can do is you can say, hey, now I have another number which is 2 and this can again be my I, my j and my k. Will I want this as my I? No, because my I is 12, which is fixed. So I will keep my I. Do you want this as your j? No, I don't want it because if I want 2 as my j, then in that case, my current I is 12, right? And 12 minus 2 will be 10. But I already have a difference of 11, right? So why should I take j as 2 and create a difference of 10? I already have a better value. So in that case, 2 cannot be your I, 2 cannot be your j, but can 2 be your k? Well, it can. And the reason is your difference factor is 11, right? And your new multiplying factor is 2, right? So in that case, 11 multiplied by 2 is going to be 22, which is a better value than the current result, which is 6, right? So we are going to say 2 is our new k, 22 is our new result, and 11 will still be my difference. And then again, when we process the input 7, we can say that, hey, 7, you cannot be my I, because I already have a value of I, which is 12, which is better. If I take you as my j, then 12 minus 7 is going to be 5. Then my difference factor is going to reduce, because I already have a difference factor of 11. And when I have a k as 7, then it can say, okay, k can be 7, because the difference is 11. 11 multiplied by 7 is going to be 77. So 77 is my actual output. So in that case, I can say 11 multiplied by 7 is 77, right? So I can definitely put this as my last k, that is, the value of I will remain as 12, the value of j will remain as 1, and the value of k will be 7 after processing all the data. And the output you are getting after putting it into the formula is 77, which will be stored in your result. So that is the complete understanding and the complete thought process of solving this question in O of n time complexity. So now, since we know the approach to solve this particular problem, we are going to jump back to our code editor and try to solve this in Python. So first of all, let me get rid of this loop. Okay, the rest of the thing we can keep. We need a value of I, right? So I will initially be 0. This will be your maximum value, which you will maintain after processing each data. Then there is another value difference, which will initially be 0. And now let us try to process each data in our input one by one. First of all, we are going to update our result at each point. So result is going to be the maximum of two things: my current result and my current number n multiplied by my current difference. So initially, till the point we do not get a new difference, we will still not have a result and it will be 0. But next we are going to update our maximum value, or the value of I, which will be maximum of two things. Either the value of I will continue, or the new number can be the maximum. And the moment we get a maximum value, which is I, we can create a new difference out of two values: the maximum of my current difference, or let's say I minus n is going to be my new maximum. After processing the data, the result will store our actual output, and we can just submit the code, and you will see that this code gets accepted. And now you can see the runtime and memory both are very optimized, because we are using the minimal memory and the best code for this particular problem. So I hope this particular explanation explains you clearly that how can you solve this problem in O of n time complexity and O of 1 space complexity. And that's it for this video. If you understood something from this video, if you did like the video, then make sure that you hit that like button. And also I would request you to type in the comment that you did like this particular video or you did like the explanation. But if you have some feedback, if you have some questions, that also you can put in the comment box. And again, that's it for this video. If you're not subscribed to my channel as of now, then make sure that you subscribe to my channel, and I will see you guys in the next video. Thank you for watching this video, guys.